The CIS 294 software engineering project is centered around a Symfony-based application that provides the front-end website, back-end database, and REST API that allows all of the other applications to talk and share data between themselves. But what is Symfony and how does it help us manage this project and keep all this code together? Let's take a quick look. For this example, I'm going to go back to a demo that was created from an older project in class where we had a product table that was full of baked goods. So I have the output of a sample table here, and here's the PHP code that can be written to generate this page using just simple PHP and writing everything from scratch. However, as we dive in, we notice that there are a few problems here. There are several lines of code that must be repeated for every page with database access. We have to do everything by hand, and we have content retrieval mixed in with presentation, making the code harder to read and maintain in the long run. This is where a framework like Symfony can come in. Symfony is a PHP-based platform that gives us a couple of things. First of all, it gives us a set of reusable components, code that we don't have to write every time we want to do something, and a framework for web projects that lets us do quick development without a bunch of repetitive coding tasks and with a lot more control over how everything fits together. To work with Symfony projects, we need a PHP-based web server installed and we need Composer installed. There are other videos and tutorials for this class that show how to set up that platform, so I'm not going to go into detail about those things. Creating a brand new Symfony project is as easy as running Composer create project, but we don't have to do that here because I've already created a new project for your class this semester. Scrolling on down to setting up an existing Symfony project, we see that all we need to do is cd into our projects directory, git clone the project that already exists, and then change directory into that projects directory and run Composer install. Let's look at that process. We go to the gitlab.hfcc.edu website, find the project for your semester, and copy the URL for cloning. Here I've moved into my projects directory, verified that I'm running PHP 8.1 and Composer version 2, so I can clone the project into a directory, which I'm calling Dragonfly based on the Fall 2023 project, and then I cd into the Dragonfly directory. Once this is done, I can run Composer install, and it will start downloading packages needed for my project. Once I've downloaded and installed the project, and I've completed other setup steps that are listed in tutorials on the CIS Linux website, I'm ready to check to see if there are any database updates to install. Symfony comes with a bin console command, and one of the things I can do there is do a Doctrine migrations list to see if there are any migrations ready for me from the Doctrine database system. In this case, we see that there is something to run, so we'll run the migration, and then we can check again when we're done and we see that everything has been run and is ready to go. If I look at my database in phpMyAdmin, I'll see that I have a table that's keeping track of my Doctrine migrations and a table for the internal Symfony Messenger service, which is created for one of the packages available in your platform, but we probably won't use during the semester. For this demo, I now want to make a products page similar to the one shown earlier in the video. Whenever we start working on the project, we always want to move away from the main branch of our Git repository and switch to a new branch to work on our feature. Here you see I have created and switched to a new branch called Add Product Entity, where we're going to add the product entity and then display it and create a REST API to share this information with other applications. When we run bin console, you'll see that one of the commands here is make entity. Instead of writing all of the code for our new entity type by hand, we're going to let the console make this entity instead. I simply run bin console make entity, specify that the class name I want is product, and then start adding fields. If we look back at the original product list, we see that we have a title, a description, a category, the quantity in stock, and a price. Notice that we don't have to create a product ID. IDs are automatically created for every new entity type and are set to be the primary key for that table. Here we're going to add fields for name and description, followed by quantity and price. Finally, we'll add a string for the category. When we're done, Symfony prompts us to create a migration. So I'll run that command now, which creates a file in the migrations directory. Let's take a quick look at the code that the console has created before moving any further. If we look at the product entity definition, we'll see that it creates an object with a class name of product that has the ID, the name, description, quantity, price, etc. When we look at the migration that was created for this, we see that there is a create table SQL command that will run to make the table for our products. The only step that we need to perform manually on this file is to add a description near the top that will show up when we list available migrations. I'll add a description here for add product table. When we list our available migrations now, you'll see that the add product table migration is available and hasn't been migrated. After running the migration and listing again, we'll see that that step has now been completed. And if we go back to phpMyAdmin, we'll see that a table has been created. I'll go ahead and add some data to this table as well so that we can demo how to get information back out using Symfony. We should stop and commit every time we know we have something working so that future changes can't break code that's already been tested. In order to make pages in a Symfony application, we need to create a controller. In this case, we'll use the console to make a controller called product controller. When we do, you'll see that it added two files to our project, the product controller and a product template. Symfony uses a template engine called Twig to render information into HTML pages. The Twig documentation is very useful and contains helpful instructions for all of the functions available in Twig. I don't really like this directory structure for templates, so I'm going to go ahead and move some files around and add some other templates to the system so that we can move on with this demo. Symfony applications ship with a template called base.html.twig, which is intended to be the page wrapper for all of your projects. However, I have found that the base template sometimes gets updated when you upgrade Symfony, and it's best to just leave this file alone as an example and create your own template. I've created this app.html twig file using the HTML from my old demo, and I've also brought in the CSS file. You'll notice a couple of things different here from regular HTML files. The link to our product page uses Twig's path function to build a link. And then down in the main content section of the page, we see a section marked block body and end block, which is where the content for each page will be inserted from another template. You may also notice that the copyright message in the footer is using Twig to generate today's date and display it as a year. I've adjusted the template for the products page to simply show the page title and a message. So where do we get this message? Let's take a look at the product controller. I've changed this controller a little bit from the one that was created by the console maker tools so that it calls the correctly renamed template and sends a value for the message that we want to display. If we view this page in the browser, we see our message got inserted where it was supposed to be. I should also mention about these templates that because we're not building a complete content management system in this project, we'll also use Twig templates like this to build all of our static page content. We want this page to read products from the database and display them. So how do we get this information? When we created our product entity, Symfony also created a product repository file. This file contains some code needed to retrieve and store information in the database. With the help of Symfony's auto-wiring features, we can add the product repository as an argument to our products method in the controller. Now we can just use the findAll method on the repository to get our products. And as a quick test, we can use the dump function to display this information to make sure that everything's working okay. If we'll reload the page, we now have a data viewer down in the toolbar at the bottom of the page. If we hover this, we can see the array of products that were retrieved, and we can click to spin open to look at individual products. Adding this repository parameter on our products method is great when we only have one page, but we know we're going to want to reuse this repository over and over again in our controller. A better way to handle this is to add it to the class constructor so that it's available to all methods. I'll talk more about this in detail with the backend web team in the coming weeks, but we'll see later in this quick overview how we're going to need to reuse the product repository for multiple routes. Now we can rewrite our code to send the products to the Twig template. We can also use the dump function in our template for debugging the data there too. In this case, the dump data shows up right in the page wherever it was included in the template. What we really wanted to do is display this data in an HTML table like we did in the original demo. And you'll see here that that is very quick and easy to do in Twig. We passed in an array of products, and we can quickly display the properties by inserting them in our markup. If we look at our product page now, it looks just like our original product page from our hand-coded PHP. Note that the toolbar has some other features that are useful. If we hover the database queries, we can get a summary of information about that query. If we click on the toolbar, it'll open up the profiler, giving us lots of debugging information about our project. We've created a product list in HTML for our end users. What happens when we need to share this product list with other applications, such as our desktop and mobile applications that we're creating for this class? In this case, we need a REST API to send the data. Our REST API will send data to remote applications using JSON, JavaScript Object Notation, which is an industry standard way of passing information back and forth. The JSON API spec is a set of rules for sending JSON back and forth between applications. This is a very long and complicated specification, and while we won't follow all of the details of JSON API, we should follow the rules for top-level members, especially that the top level of our JSON response should always contain data or errors, but must never contain both. The primary reason for our API are the desktop and mobile applications. However, it's good to have a tool for testing and developing these APIs. For that, we'll use Postman, which is a free utility from postman.com. You will need to create a free account in order to use Postman. I recommend using your school email address for this account. Adding an API endpoint to our existing products controller consists of only a few lines of code to build an output array and send it back using the JSON method of the controller rather than the render method. You might note that we didn't actually define render or JSON in our controller. That's because our controller extends the abstract controller built into Symfony, and we can use all of that code without having to add our own. Note that this is a simple example, and most of the endpoints that backend team will create will need security checks before allowing users to retrieve data. Note that we're making an array that has a top-level value of data, and then inside data, we're returning the products. If we wanted, we could probably skip a layer here and simply return the products as the data item. When I view the results in Postman, you'll see that it contains all of the baked goods items that we stuck in our products table earlier. In order to secure our API, we'll set up some login procedures, and we will use JWT, JSON Web Tokens, as a way to ensure that the user making requests is properly logged in. Here's a quick example of how that works. Here's an example login using the API from a previous semester. We pass the username and the password as the body of our request, and we return the user information and a token. You'll see that this endpoint doesn't return data, so it needs to be improved to meet our current standards. But the important thing to see here is the token. We'll now use the token to authenticate to get a list of all the users. And the site sends back all this information because we did, in fact, provide the token to prove that we've already logged in. There is, of course, a lot more to this project, and we'll have a lot of things that we need to decide, define, develop, and test. However, that's a quick overview of how we'll use Symfony to provide database support, front end, and back end for our project.